welcome back to the last of our videos on factoring. We're going to be wrapping this unit up with one more look at factoring applications. We're going to take a couple days to tie all this together in my class and then take an assessment on that. And then we will begin our new unit very soon on radicals and radical expressions. So those should be a lot of fun. What we're going to do here today is just look at one or two more ways that we can use factoring to help us solve problems. Particularly today, we're going to be focusing on some area problems. A couple of these can be just a little bit challenging, so you may have to pause, try a few things, rewind the video, watch again. But if you take your time and follow along closely, I think you'll be able to manage this without a whole lot of difficulty. So let's go ahead and get started. You're spending a great deal of time at home and want to brighten up your surroundings. You decide to plant a garden. The width of the garden is to be 8 feet shorter than the length. The area of the garden will be 345 square feet. Give both the length and the width of the garden. Now, one of the things that's interesting about this particular problem is they did not give us a polynomial to work with. In the applications we did in the previous video, typically either a formula or a polynomial was given to us, and all we had to do was either factor it and plug in some numbers. In this problem, we are not able to do that. Instead, we've got to create a polynomial equation on our own. So, since this is a geometry problem, which I can tell because it says the width and the length and the area, I have a rule for my students in geometry, and that is you always start off by drawing the picture. I can tell you that most of the mistakes that people make very commonly in both algebra and actually in geometry class when dealing with geometry problems is they don't fully understand what their unknowns are or the relationships between them. Drawing the picture is a huge help in organizing your thoughts. So please do not skip that part of the process. The other benefit of drawing the pictures is we can use that picture to define our variables. Ordinarily, we would come off to the side and say x stands for this and y stands for this, or x minus 5. Whatever your variable or your variable expression is, we would have to write that out in words. Drawing the picture allows us to define those variables without having to go through that process. So let's see what this says. It says blah 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 blah. The width of the garden is to be 8 feet shorter than the length. This is an information phrase. The width is 8 foot shorter than the length. That identifies both of our unknowns and tells us how they're related to one another. If the length is x, then the width would be x minus 8, or 8 feet shorter. Remember, they're going to have one unknown and then one expression based on the unknown you're given. Now, you could have said your width was x and the length was x plus 8, and that would have worked out just as well. It doesn't matter. What's important is that one of them has to be 8 different from the other. So you either know that x is the length and the width is 8 shorter, or you could call the width x and make the length 8 longer. Either way, the next sentence tells us the area of the garden is 345 square feet, and we're asked to find out what values of x would make that true. Well, fortunately, since this is a rectangle, we already know the formula for the area of a rectangle. It's the length times the width. So all I have to do is plug in the numbers and variables that I have just written down in my picture for the area, the length, and the width. Notice the area is 345, the length we defined as x, and the width we defined as x minus 8. So I just plug those values in. Now, in all honesty, that is the hardest part of this problem, because after that, we just need to rearrange it into standard form and set it equal to 0. So I'm going to distribute my x using the distributive property. And then I'm going to move this 345 over to the other side. To get rid of a positive 345, I'm going to subtract it from both sides, which gives us this equation. 0 equals x squared minus 8x minus 345. Now, I did do that fairly quickly because for the most part, we're just plugging in numbers, distributing, and using the property of equality. This should have been pretty simple. If it's not, you are going to want to go back and watch some of our videos on equation solving, because this should not have been a terribly difficult process. However, at this point now we have to go through and do some factoring. So I would suggest to you that you pause the video, you factor this on your own, solve for the variables, and then restart the video to see if what you've done matches what I'm doing. I'm going to assume you've already done that if you plan on doing that, and I'm going to work through this as well. I'm going to go ahead, use my symmetric property and put my equals 0 on the other side. That's more comfortable for me. It is not required for you. And then I'm going to go ahead and factor this. I know the only way to get an x squared is to have an x and an x. I know by this negative 345 that these signs are going to be different, because a positive times a negative is the only way to get a negative 345. Now this is a pretty involved problem, because I have to start looking for what things multiply together to give me 345, and then figure out which of those will add up to be a negative 8. So 1 times 345 works, but that's not going to add up to negative 8. Because 345 is an odd number, I know 2 times something is not going to work. I can look at the digits, 3, 4, and 5. Those add up to be 12. We have a pattern in math that says if the sum of the digits is divisible by 3, then the number is divisible by 3. So I knew that 3 would work. And when I divide that out, it's 115. That's still not close to negative 8. Because the 2 didn't work, because this is an odd number, I know that no even numbers will divide into 345, which means I really don't even need to check the 4. If I want to look at the 5, I can see this ends in a 5, so it will be divisible by 5. It's 5 times 69, and you can see we're still a long way away from getting this 8. These numbers are going to have to be pretty close together in order for me to get an 8. But this is becoming very tedious. So here's what I'm going to do. I'm going to show you a little hint that we did not talk about through these videos. If we had met in class, we would have done that, but since we're doing this all with online learning right now, I skipped over that. Now's a good time to mention that there are ways to help you with the guess and check. And that's this. Rather than just going through and trying 6, 7, 8, 9, 10, 11, and so on and so forth, which is going to take me a long time, I can look at this, and I can look at this 69 and realize, wait a second, 69 can break down into prime numbers. In fact, I can bring my 5 down, and I know that 69 breaks into 3 times 23. Notice 5 is prime, 3 is prime, and 23 is prime. If you can take this and break it into its prime factors, you can reorganize and regroup this multiplication into basically any other combinations that you want. Notice that if I keep the 3 by itself and I combine the 5 and the 23, that's going to give me the 115. We already did the 3 and the 23 together. That gave me the 69. But if I put the 3 and the 5 together, that's going to give me a 15. 15 times 23 is the other pair of factors that multiply together to give me 345. Now, I could have just gone through and done 6, 7, 8, 9, 10, 11. I could have tried everything, but this seemed like a nice little shortcut to show you. If you can look at things once they're into smaller numbers, 345 is pretty big. Once you've got a set of smaller numbers that work, sometimes you can look at how to break this down and reorganize it and recombine it in order to make the guess and check process easier. Now, I do have one of these as a plus, the other's a minus. I want to end up with a negative 8. That means the 23 is going to need to be the one with a negative sign. So I have x plus 15 and x minus 23. From there, I'm going to use the zero product property to solve. Either the x plus 15 has to be a 0, or the x minus 23 has to be a 0. A lot of my students in their work are skipping this step. You really need to write this step out because it does cause people to lose track of whether signs are positive or negative when they skip this step. I solve the first equation by subtracting 15 from both sides, get x equals negative 15. That doesn't make any sense because the length of a rectangle would not be a negative number. If I go through and add 23 to both sides of this one, I get x equals 23, which is our correct solution. Now notice the question does say give the length and the width. You have just found the length, which is 23. You know the width is x minus 8, which is 15. So there's your solution. It is not a coincidence that, that this was a negative 15 and the width was a 15. So that might be something to file away in the back of your brain. When you get this final solution, a lot of times even the solution that did not work has some significant meaning. We knew the two sides were 15 and 23. We just weren't sure which one was the length and which one was the width. By solving and finding out which one was positive, we were able to find out that the length was the 23. Now, that is a fairly long process, but if you keep track of the steps over here, it really is not a complicated process. The only real challenge is, number one, getting the picture set up so that it actually represents the problem. This is where most students make their mistakes. The second spot that's a little bit difficult is trying to find the factors of 345. And there again, that's just sometimes a sitting down, taking your time, being cautious, and grinding it out. Conceptually, this should not be an overwhelming process. Let's try another one that looks slightly different. The photo you have on your desk of your favorite teacher is not large enough to keep you inspired during distance learning, so you decide to increase the length and width by the same amount. The original picture was 5 by 8 inches. The new photo has an area that is 4.5 times the original area. How much did you increase the sides by? I do need to go back and give you a fancier title for this because we're no longer talking about farm stuff. I'll make sure I do that before I print this for my students. Once again, this is an area problem, so I am going to draw myself a picture. I did draw it upright because my original picture was upright. It really doesn't make a huge difference if you want to draw that sideways. I just wanted to be consistent so I didn't confuse anybody. We know the original picture was 5 inches by 8 inches. So there's my 5, there's my 8. They didn't tell me the area, but I can compute that as being 40 inches squared. Let's go back to our original problem. It says you decide to increase the length and the width by the same amount. So I'm going to take this and I'm going to make it bigger. Notice I had a small rectangle. Now I have a larger rectangle. Some people prefer to draw the new rectangle off to the side. I thought because I could actually type and use the computer to make it nice and neat, it would make sense to go ahead and just draw it on top. Now, it is important to remember that we increase them by the same amount. What that means is that if this was 5 before, I'm going to add x to this side. Since this was 8 before, I'm going to add x to this side, so I'm adding some unknown amount. Here's where people tend to find this to be a little bit difficult. If I want to know the area of the new rectangle, I have to use the new width and the new length. Or I think do we use height and length? No, width and length. I need a new measure for this, and I need a new measure for this. So we have to decide how long this side of the rectangle actually is. Before, it was 8, but I added x to the other side. That means this whole side is now 8 plus x. Did that make sense? It was 8. I added this much more. I added x more for a total of x plus 8. Remember, the left and right sides are both the same measure. When I go to find the width used to be 5. That's written right here. But I increased it by x. Remember, this and this are the same size. So how long is it now? Well, from here to here is 5. From here to here is x. The new width is x plus 5. And the last piece of information we're given is that the new photo has an area that's 4.5 times the original. The original was 40. That means the new area is 40 times 4.5, which is 180 square inches. Now, you can probably see that this is a lot of information, and this can very quickly become confusing. That's why I tell people you need to make sure you draw the picture. You need to make sure it's neat. Notice that I didn't worry about drawing it to scale. I just drew any generic rectangle, but I did fill in the information that I was given, making sure that I didn't leave anything out. Because once this is done, setting up the equation is not hard. We know the area is length times width. All we need to do is plug in the values. Remember, we're looking for the new length and the new width. That's the x plus 5 and the x plus 8. We also are working with the new area. So I just plug those values in. I think I switched my length and width here. The length would have been x plus 8 and the width would have been x plus 5. But here again, it doesn't make a difference because of the commutative property. Once you've got the equation written, once again, we're going to put it in standard form equal to 0. I'm going to recommend that you pause the video, you try that on your own, and then restart the video. I'm going to go ahead and work assuming you've already done that. I need to multiply these two binomials together using the FOIL method, x times x, x times 8, 5 times x, 5 times 8. When I do that, I get x squared plus 13x plus 40. If that's a struggle for you, you're going to want to go back and watch the video on multiplying polynomials. Once I've done that, I need to move this this 180 to the other side by subtracting 180. And that puts us here. And just like before, it makes me feel more comfortable if I use the symmetric property and say that the equal 0 is on the other side. It doesn't really matter which side the equal 0 is on. You just want it in a spot that's easy for you. Once it's in standard form, you need to factor this in order to solve it. I'm going to go ahead and recommend that you take some time and try that on your own. I'm going to keep going. I'm assuming that if you wanted to do that, you already have. So when I break this down, I can see that the only way to get x squared is x and x. I can see that this is a negative 140, which means these two signs must be different. What I need to do is find out what things multiply together to give me 140 that also add up to be 13. Well, let's see. 1 times 140 works. 2 times 70. 3 times 3 doesn't go into 140. 4 times 35. 5 times 28. 7 times 20. And of course, the 7 and the 20 are the ones that work. Notice that I didn't take the time to do the prime factorization of 140 like we did in the previous example. That's because 140 was a much easier number for me to do mentally, so I didn't bother. Certainly, you could break 140 into factors and work it out that way. If you did that, you would have, let's see, 2 times 2 times 5 times 7. And you could reorganize and regroup those to make all the other options. Notice that since it's a positive 13, I know that I need a plus 20 and a minus 7. That's the way I end up with a positive 13 instead of a negative. And then I just separate this using the zero product property. X minus 7 is 0. X plus 20 is 0. And I solve those, 7 or negative 20. Now, because we're talking about how much we increased the sides, negative 20 would not increase the sides, it would decrease the sides, it would actually make the sides negative, so we know that answer doesn't make any sense. The x equals 7 must be our increase. Notice, by the way, the question says how much did we increase the sides? We have our solution here. If I wanted to find the new measures of the sides, I would just plug the 7 in and figure that out. 7 plus 8 means this side would be 15 now, and this side would now be a 12. By the way, 12 times 15 does equal 180. That's exhausting, isn't it? I know that's a lot of steps for a single problem, but hopefully it makes sense as you're working your way through it. Here we go. The last one. This one's the one that people have the most difficulty with. Here again, I do need to change the title on that, although I guess I could have a tablecloth on a table in my farm. Either way, let's see what we got. A tablecloth measures 4 feet by 5 feet. First thing I'm going to do is draw that picture, 4 feet by 5 feet. I also happen to know that I can find the area is 20. No big deal there. Let's keep going. A border of uniform width is added around the edge of the table. Now this is really important because this phrase, border around the edge, is kind of a sticking point for my students. If they're not careful, they have a tendency not to realize what that means. So I'm going to underline it. I'm going to suggest that you underline or star or circle on your paper that phrase. A border of uniform width is added. If you can see this tablecloth that I have in the picture, you can see there's a dark green section. In our problem, the dark green section would be that 20 square feet. that 20 square feet, that 4 by 5. But you'll notice that this is added around the outside as a decoration. So I'm going to also add that to my picture. Probably would have made more sense if I had made my picture dark green and green. Maybe I'll go back and change that at some point, but I don't think it's too big of a deal. Hopefully that makes sense anyways. Now, here's what happens. When we add that border, that new section adds 36 square feet. So my area used to be 20 square feet, but I'm adding 36 to that. Keep that in mind for just a second. Let's come over here and let's fill some things in. It says, what are the dimensions of the cloth? Let's think about our unknown. The one thing I don't know in this problem is how wide is that border? That's not told to me. I'm going to have to figure that out in order to figure out what the new dimensions are, because I don't have any measurements given to me for the whole thing. So I'm going to start to fill in some pieces. Notice the uniform width says the distance from here to here, or in the case of the green tablecloth, the distance from here to here is always going to be the same. That's the definition of uniform width. So I'm going to call it X. Over here on the other side, because it's uniform width, this is also X. Notice that from here to the top, it's uniform width. That also needs to be X. And down here at the bottom, if it's uniform width, that also is X. In fact, no matter where I draw a line from the original tablecloth to the edge of the new tablecloth, it should be X. It's important to realize that when we go to find our new length and width, because from here to here, we said was 5. Here, all the way down to here. But our new length now also adds on this and this. Can you figure out what that new length would be? You may want to pause the video and look at it or think about it for just a second. I'm going to assume you've already done that, and I'm going to tell you this is 2x plus 5. You have x from here to here, 5 from here to here, x from here to here. Now I will tell you, in my class, this 2x plus 5 is where most of my students end up missing this problem, because they get in a hurry and they don't realize that they've added a border or they've added extra length to the top and to the bottom. They end up just calling this x plus 5 and they end up with an incorrect border. So be conscientious or aware of that. Let's talk about the other side. I'm going to erase some of these marks because that's getting to be quite a bit. Originally, I'm going to change the color of my pen as well. Let's go with green. Originally, I had a width of 4. That was from here to here, or from here to here was 4. But now I've got more length over here. That's x. And I've got more length over here, that's x. So if I take this x and this 4 and this x and I combine those, my new width is 2x plus 4. Again, the 2 is really where people tend to miss this problem, because they forget that you've added a width to this side, but you've also added it to this side. And you can see that here, here, and here. It's the 4 and 2 x's to get all the way across. This example is probably the most difficult out of all the application problems we're going to do. Fortunately, you've already done the hard part. Don't forget, you also know that the total area is 56. That's the original 20 and the 36 that you added. Let's just write our equation. Length times width. I'm going to substitute in the values that we just said. That is a length of 2x plus 5 times a width of 2x plus 4 equals my area of 56. And just like before, I'm going to put it in standard form equal to 0. Again, I'm going to recommend you pause the video and try and work this part out on your own. I'm going to assume you've already done that, and I'm going to tell you it's 4x squared plus 18x plus 20. I'm then going to move my 56 over, and here is my quadratic trinomial. Now, once we've got it in that form, I'm going to go ahead and make it equal 0 instead of 0 equals. That's the symmetric property. That is optional. But once it's in that form, I'm going to have to factor this. This is another spot where you probably want to take some time and try it on your own before watching me do it. I'm going to do this slightly differently than we did in our videos in the past. If we were doing lessons in class right now, I would have showed you this method already, but because we're doing it online, I did leave this method out. So the method I'm going to show you is optional for you. You can do this by the guess and check method the way you've always done it, but I at least wanted you to see an alternate method that you could use that might save you some time. Always take out your GCF first. If you forgot to take out the GCF, you need to make that a habit. Always look for it. At this point, we know the only way to get 2x squared is to use a 2x and a 1x. We also know that our signs are going to be different, and we can see that we're going to end up with a positive center number. At this point, what most of my students would do is they would look at this 18, and they would go through here and say, okay, well, 1 and 18, 2 and 9, or 3 and 6. And they would guess and check their way through until they found the right answer. I'm assuming if you paused the video, that's what you just did, and that's fine. But here's another thing you could do. You could go through, and I'm going to erase my ink here so it's less confusing. What I'm going to do is I'm going to go through here, and I'm going to take this 2 and this 18, and I'm going to multiply those together and get a 36. And rather than looking for factors of 18, I want to look at the factors of 36. That's 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Okay? Here's what I know. I know that when I'm finished, the numbers that I pick have to have a product of 36, but I want to have numbers that are going to give me a 9 in the middle. A 9 in the middle. So I'm looking here and I'm seeing this 3 and this 12. That's very interesting to me because I know my signs are going to be different. And I know a -3 and a +12 are going to give me a +9. And so what I'm going to do is instead of just plugging in and guessing and checking like we've done before, I'm going to separate that 9x into a 12 and a -3x. It doesn't really matter which one you put first. It's going to work out either way, but I happen to like putting the 12 first, and you'll see why here in just a second. Notice that you have taken your trinomial and you have turned it into a 4-term polynomial. Now, it's not in simplest form, it's not in standard form, but it is a 4-term polynomial. So instead of using the guess and check method on this, we can use factoring by grouping on this. Think about this. When we factor by grouping, we're going to hang on to the 2, but we're going to ignore it. And we're going to split the first 2 terms into a group and the second 2 terms in a group. And then we're going to pull out the GCF of the first group, pull out the GCF of the second group. The first group had a GCF of 2x. The second group had a GCF of a -3, and this should become a 1. There's a little typo I've got to fix. Notice that when you pull out the GCF, what's inside the parentheses is the same. That means that I can take the 2 and bring it down. The 2x and the -3 give me 2x minus 3. Both of those get multiplied by the x plus 6, which gives me the x plus 6. You see, what we've done is we've used the grouping method to solve this instead of guess and check. Most of my students, when they see this, prefer to go on guessing and checking. And if you do that, you can actually get from here to here without doing all these steps in the middle. But it is a lot of trial and error. It is a lot of writing and erasing and testing. So if you like guess and check, please continue to do that. That's fine. However, if you're somebody who absolutely hates guess and check, This is another method that you can consider working with. This will come out correct every time, but it does involve a little bit more writing. If you're not real comfortable with factoring by grouping, this may not be the method for you. Either way, once you get down here, it's in factored form. So you have three factors that all multiply together to equal 0. So you're just going to use the zero product property to solve. Either the 2 has to be a 0, which makes no sense. The 2x minus 3 has to equal 0, which means x equals 1.5. Again, add 3 to both sides, divide both sides by 2. Or x minus 6 has to be a 0, which means x is a negative 6. Well, that doesn't make any sense at all because you don't want to have a negative length if you're adding a border. That means the 1.5 is how long your border is. Now, it's important to remember, the question does not ask how large the border is or how wide the border is. It asks what the new dimensions are. The new dimensions are 2x plus 5 and 2x plus 4, which means your new width is 2 times 1.5 plus 4. Your new length is 2 times 1.5 plus 5, which means your new dimensions are 7 by 8. Now, keep this particular example in mind. This is the most troublesome example that we will be working with in this unit. This is the last of the application problems. This is the last of our factoring unit. So congratulations to you guys on completing this. As always, make sure that if you had some trouble, you go back and watch it a second time. Sometimes watching and viewing one time isn't enough, and the second time you can really kind of focus on what I'm saying instead of trying to get the notes copied down. You guys, thank you so much for watching. I do really appreciate it. Make sure that you leave us a like, click that like button, turn on your notifications, ring that bell, all those cool YouTube buzzwords. Make sure that you're following along with everything we're doing here at Nunley Math. I do wish you all the very, very best. You all take care of yourselves, all right? Bye-bye.